So SendMail and PostFix both support what they call milters. This is a library with hooks that will let you write your own processing application that will receive pieces of email as it comes in, and you can say, nope, I don't like it. Oh yeah, it's still okay, I'll take that one. So you can cut things off at the pass. The basic architecture of this is you've got your mail transfer agent sitting out here. It calls into the library, kicks off every piece of mail, gets put into its own little environment, which will be one of n threads. And then it goes into a set of callbacks, which again is one of those things that we're kind of used to. This is event-driven programming, these callbacks. And depending on what it is, in this case they diagrammed it for header, or maybe the connection callback, or something like that. So I wanted to do this in Tcl. That seemed like a reasonable thing to do. Like I said, email is text. Text is, that's what we do. So there's a Tcl milter out there. It was written by Michael Kirkham of Muonix, and it's available online. So I sucked that down. The good news is that it exists. And the Tcl milter architecture is not horrible, but it's not the kind of thing you sit down and read like a novel for the first time. It's one of those novels you read 2 or 3 times before you say, oh, it really was a bummer. And he did a nice job. It's a good basis for the architecture. The problem was that he wrote this thing 5 years ago, and milter has been a moving target in that time frame. And he's not using SendMail or PostFix anymore, so he's had no way to do any more testing, because he doesn't, unless he builds up a system just to do testing on. So it hasn't been maintained, and out of the box it doesn't work. The initial fix wasn't too bad. I sent that into it. He's agreed that that was probably a good thing to do. The real problem comes in that what the milter library does is nasty stuff. They create a context for each email that comes in, and because you may have more emails than you have threads, they create a context within each thread. And part of that is that they blow away some thread persistent data, which is what the Tcl thread extension uses to know whether or not the interpreter has been initialized yet in this thread. So what ends up happening after way more spinning of wheels than I've ever done in a nasty snowbank, it appears that what's going on is that we have a thread. It will get multiple contexts. It'll get a Tcl interp for each one. That's not a problem, but each interp ends up being initialized separately, and that makes a memory leak that's on the rough order of 2 gigabytes per hour on a Fuzzbox mail server. It worked really nice when I tested it. Then I hooked it up to my mail server, and an hour later I'm watching the swap daemon is chewing up 90% of the time, and I'm running out of swap space. So I ended up doing a little bit of kludging to Tcl thread to add a new command so that I can explicitly destroy the initialization rather than doing it when the thread closes. This is a kludge, Andreas, and what is the Tcl thread? Who is the Tcl thread author? Zoran. Yeah. He and I exchanged mail. We've all agreed that we don't like my solution, but it put my memory leak down to the order of thousands kilobytes per hour instead of hundreds of megabytes an hour. So I've been using this Tcl milter is in use. I've been running it for about 3 months now. I haven't had any crashes. What I do have is a cron tab entry that every night stops it and starts up again so it doesn't run out of memory. I haven't caught rejecting any valid email. Nobody's called me up and said, hi, how come you never answered me? Because I've been able to build custom filters quick and easy, I've managed to get another factor of 10 reduction on my emails, on my spam mails. Because one of the things with email and spam is it changes fast. A couple of years ago, I came home one day to discover that I was getting 20,000 emails in an hour of spam, and they were all identical. In that particular case, I used my my sorting program, grabbed the MD5 package out of the Tcl lib, and did an MD5 of each message. And if I'd already seen that MD5, I threw it away because it was filling up my disk too fast. One of the confusing things on trying to write a Tcl filter is that when mail comes in, it is given a new filter, a new thread. And that means that each piece of mail goes into its own thread. And Tcl interpreters are happy with this. But if you're going to do something like that where you want persistent data, you've got to remember that this is a thread that's going to go away. And if you want any persistent data, you're going to have to send that back up to your parent thread. And in fact, all the other little minor trick is that the thread that initializes the milter never returns until the milter is crashed or is terminated. So you're going to have at least two threads. Well, at least three threads, because you'll have the one that called in to Tcl milter to initialize things and never came home, a master thread that you're using to control everything else, and a per email thread. What I did was I put together a little library of my own that gets that per message thread, and all it has in the per message thread is something that calls up to the main thread, so that you can write filters in the global scope. And you get the context identifier for each email, which is just really easy to use the old upvar trick to map into a global Tcl variable that you can use to distinguish between whether this is the email from my bank or the email from my mother. And it just, it works fairly nicely, and it saves me from having to be constantly sending things back and forth, because this is what I want to say, this is what I don't care about. I care about everything. So this made it real simple to write a gray list filter, for instance. Anybody not familiar with gray list? Okay. The concept of a gray list is that whenever you get mail from somebody you don't normally correspond with, you refuse it. But you refuse it with a temporary refusal. And you put them in a list and you say, if they come back, then I'll let them in. Because most of the spam bots just go through and try once. But the postman always knocks twice. So real mail servers will come back again for up to 4 days. And setting up a gray list was good for cutting out about 50% of the spam that makes it through the door. Okay, so that's where things are now. Future, I would like to do something about the thread problem. I thought about taking, rather than using the thread static data that the thread package uses now, and set up my own little hash table and track it there. And it worked in my test. This is one of the things that's an issue with dealing with things like email, is you do tests in onesies, twosies, then you throw it out into the world and the wolves attack it. It worked in my tests. They ran for about 2 hours, and I got 4 dumps out of the NRE. Andre suggested that rather than using the 8.6 code, I go back to the 8.5 and see whether or not I'm doing something stupid or I'm actually managing to break the NRE somehow. Downside from all of this, writing email stuff is not my business. Nobody pays me when I'm doing that, so this gets worked on when I'm not doing something for somebody else. And like too many of the other people that have worked on this sort of thing, I solve it until it's no longer a problem for me, and then I drop this project. So things don't tend to move to a distributable product or a project. Any questions? Any answers? Good answer.
The useless bit of information today. Do you know that the fact that we know that Bayesian networks work well for spam filtering can be attributed a little bit to Tcl? Yes.
Oh, it comes out of your work?
Yes, actually, the first paper that had applied Bayesian networks for spam filtering comes from a guy in our lab, which also distributed a corpus, the first corpus, that contained spam and legitimate emails for benchmarking the various approaches. The author is called Ionas Avlopoulos, who was in our lab, and this corpus was built 80% from my emails, my spam emails, and my correct emails, with which I was the guy with the most spam emails in our institute, due to the fact that I was writing in Complag TCL with my real email address. So from day one, it was a very popular email address for spammers. So I had so much spams due to the Complag TCL news group that the first spam benchmarking corpus was built. So TCL in everything.
Okay, my first time in front of you. I don't believe I have to reintroduce myself. So I jump straight in. This yesterday diagram was basically vector images, vector diagrams. Today it's now raster images. And TRIMP, C raster image manipulation package, is quite a torturous acronym. On the other hand, it's not as bad as Jean Wood's Lovecraftian horror. So, okay, as a bit of background, it is, well, given that nearly everyone should be in a picture I have shot during the last 2 days, it shouldn't be a surprise that I was gotten bitten by the image processing bug. And well, TRIMP is mainly the result of that. It is also very new, only 2 months old, with mostly in the evenings, so it is definitely a work in progress. And the rest of the paper is basically the usual stuff, namely a bit of background why, and looking at other stuff which might be of interest and I maybe could have used, and then what I have implemented so far, what I haven't done, and from that, of course, what I should do possibly in the future, and at the end, a nice small demo of what I currently have. So the background, as I said, is image processing, and what we currently have in Tcl TK is more or less resampling, resizing a bit, and a bit of rotation, I believe, or maybe not. And I wanted to have lots of more stuff like any point operation you can think of, neighborhood operations, in other words, filtering, and then for the far future, really high-level stuff like document analysis, debugging something. That comes out of a different thing. When I said image processing bug and shooting you, that is more or less like photoshopping. But with these high-level stuff, I'm more going to document analysis. That is another area where I have a bit of interest, and where, for example, I'm tracking these do-it-yourself book scanner people, which basically use a camera and they take pictures of a book page by page, and then they process it and have a nice ebook, basically. And that is then the far future high-level stuff which I want to get to and which I have no idea about. And one of the goals is to be independent of TK, which is, well, we have on the image processing what we have in TK. We are tied to an X11 server, and while we could do something like an X11 frame buffer server, it is actually something awkward. So it is better to have something you can do on a server without any display at all. That is something I haven't actually reached yet either, although I believe I am better than others. So what else? Yeah, we have quite a lot of image stuff out there, as I found out. On the other hand, they were not really what I liked or what I wanted to do, or the license was not really matching. Like Pixane is not free, it's commercial, and other stuff. The nearest I found is more or less Tcl Magic with image based on image magic, graphics magic, and that didn't look easy to build. So in the end, not invented here, doing my own. And I believe it's best to first say the limitations. As I said, it is only 2 months old, very, very new, and I still have it tethered to TK. On the other hand, I believe I am better than the others. I am not entangled with it. I have only 2 files, which basically convert between the images, which are values, Tcl objects, and to TK photos, forward and backward. And if you remove that from the package, then you are definitely TK-less. And I'm currently loath to remove it. I still need some way of showing results of what I am doing, of operations I am implementing. So that is actually something where I want to talk to Steve Landers a bit about, namely I am using Critical underneath, and I hope to get some ways to split things apart, put in nice stub tables and stuff, and then I can have basically the crimp for the image processing and the crimp decay, which ties it to decay, and then everybody should be satisfied. And another thing is, of course, I have only the most basic image formats, which I can write, like PPM, PGM, basically the portable AnyMap stuff. And the build system, as I said, I'm using Critical. I don't even have a makefile on top. So it is not really something that you can put into a build farm right now and have it for whatever all platforms. I believe that I have implemented the basic platforms, but all the high-level stuff I want to go to in the future is definitely not there. And given that I'm filling with AP in places, I'm also still setting it at version 0. At some point, when the AP is stable, at least for the parts I have, then we could go to version 1. On the other hand, what do I have? I have basically the generic pixel point operations, where I'm using the lookup table. Basically, the primitive I have underneath in C takes a lookup table and then applies it basically to all pixels in the image, and that is very fast, and you can do lots of stuff already with this simple thing like gamma correction, inversion, solarization, and whatnot. And yeah, thresholds is also something which is important, and is also done by that. And another primitive is basically convolution. So this is also a generic thing. I put in the matrix of the kernel, the matrix of weights, run it over the image, and I'm done. And while I have the Gauss, Laplace, and Sobel, and so on in the demos, I haven't finalized the stuff yet, so this is in the demos, not really in the package. Next, a bit more complex stuff are so-called rank order filters, like median filters, and related to that, min and max filters. This is something I have also done. And another operation you need later in document processing are so-called morphology operations. And if you go to the most simple, they use something called structuring element, which takes the place of a kernel in other filtering operations. And the most simple structuring element is what they call a brick, which is basically a rectangle or a square of basically pixels or ones. And if you do that, the morphology in grayscale is actually an application of a rank order filters, namely the open and close operations in this area are basically min and max filters. So I got them basically for free. And after that, a number of basic binary operators, adding, subtracting images, multiplying them, stuff like that. And I do the standard rotations and reflections. I have the pieces for general resizing, but only the pieces I haven't really put them together into something nice, and it is not as fast as I like yet. Okay, I got ahead of myself. Basically, it is now on this slide. Basically, the pieces are downsampling an image or upsampling it, and related to that, decimation and interpolation, which is basically downsampling. Decimation is you do a low-pass filter and then you decimate so that you get rid of alias artifacts, and interpolation is basically upsampling and then filtering so that you fill out the empty parts between the pixels you generated by upsampling. Okay, standard stuff, conversions between a few color spaces, and as I said, the basic formats, portable AnyMaps, and Richard Suckenwurf strimges for really small stuff, and using matrices, nested list format to help me in case I do something, in case I generate something basically in the tickle side and then want to make an image of that, which is actually something I already use. For example, the filtering kernels in the generic filtering are images, and they are matrix, so I'm basically creating a matrix of values, turn them into an image, and that is then the input to the primitive. In the same manner, the lookup table for the pixel point operators are also basically images, namely height of 1 and a width of 256 values, and that is directly a directly usable lookup table at the C level. I have this in a fossil repository, and the location is here now on the slide, and a copy of this fossil repository and stuff around that to actually do the developing plus README which explains the pieces will be on the USB stick. And with that, yeah, the limitations give me a nice roadmap for the future. I have to build a build system so that I can slot it into whatever build framework there is, well, ActiveStates build framework, and separate the tickle and the parts which are decay dependent into their own stuff, and of course create more Lego blocks I can later put together into what I actually want to do. Right now I'm basically creating the bricks from which I then later build the house. The last thing is I haven't talked about yet, that is multi-threaded operations. Right now the primitives are relatively fast, they are in C. On the other hand, I am currently using them on 800 by 600 pixel images. That is small enough so that, let's say, a Gauss filter runs in a second or so. On the other hand, the moment you go to photos like 3000 by 2000, then, well, it goes up fast, the runtime. So, looking in some ways to slice and dice for operations so that you can have multiple threads operating on a single image is something which should be done to speed things up. It is not something which has to be seen at the tickle level, that is, would be an implementation detail. And with that, we come to the demo. So, am I in the right thing? Yes. Okay. First, a few operations which are image independent, like a blank image in whatever color you like, or reading various test images in the portable ANI formats. These are not really the images. Actually, I'm using very small images. For example, this one is 3 by 2 pixels, and then it's blown up basically by 64 by times 64. Psychedelia is actually something I have inherited. I started out with code I found on the wiki by Andrew Goff, and this psychedelia effect is one of his. And I simply kept it, and well. Now, the images are all mine, so there shouldn't be trouble with copyright and whatnot. I basically put them under the same license as C code, which is BSD. So, something simple. Well, where is it? Crop the image, basically take a part, or cut a part out, or let's go to unmodified back and use a Laplace filter. And if you add the Laplacian to the image itself, then you have edge enhancement. Yeah? Is this difference visible? Okay. Other stuff is, for example, like the Sobel filter. This is some edge detection filter. Then there is, of course, gamma correction. That is a bit, yeah. The plots here are all plot chart. This is very, here you actually see that the per pixel operations are really fast because this is really interactively done. inversion. What is this? This is log compression, which is, yeah. What do we have here? Quantization. Basically, I'm pre-shorting it into black and white, and actually here I am setting which are the levels. Basically, this is my white, this is my black, this is my white, but it's not actually black, but two gray levels. This was all basically about via lookup tables. And if I do more at about 16 gray levels, it actually looks already quite natural. So let's see. Interpolation, first order hold. Okay, this now takes quite a bit of time. What should be visible here, I am blowing basically the image up 4 times. And you see, it should be visible that it is quite blocky. That was the first order hold filter. Basically replicate the pixel to the left and to the top. And if you're using a nice, if you're doing just upsampling, it looks very black, but here are actually the actual pixels. And if you actually do a nice Gaussian blur filter, then you get basically it blown up and it actually looks smooth. Let's go back to the, there is, yeah. It doesn't look blocky or less blocky, quite smooth actually. So, last stuff. What do we write? This was a nice effect, charcoal. The interesting thing is, this is actually an application of morphology. It is the morphological gradient of image. And when I saw that first, I thought, oh, that looks like the charcoal. It seems I have found the effect of image magic. And what else? Oh, yes. Embossing. That is the filters by Richard Suchenwirth. And what do we have? Equalization. Equalization is basically histogram equalization, so plane, and if I do it using the value here, you can't see it that nicely with this picture, so let's go to, where is my plant. This one is a nice one, and if I do equalization, you'll see how it brings out the contrast. I can do it with saturation as well. This is now in the HSV color space. If you do this in RGB, you get also the contrast better, but it shifts the colors. If you do it with Luma and then divide things basically with color ratios, then it's actually a bit better. But that is then something the people who use the package have to know what each operation does and where they can apply it. So, and let's select 2 pictures, and then we have the binary operations like adding the 2 images together, which is relatively surreal, or blending them between. Do the difference. Choose the maximum of either, or the minimum. This has put them side by side on target and top to bottom. Multiply. That's basically what that is. Thank you. I guess you can go to dinner now.
that for whatever you feel needs to do.